Okay, so this is my attempt at a microcontroller, kind of like basically it's a rife machine. It's just a weak pulsed magnetic field generator. Because anything under like 3,000, but realistically like 100,000 hertz is not really radio frequency yet, and you can see it is oscillating there. I'm not good enough with oscilloscopes to be able to track down the frequency and do all that stuff, I'm sorry to say. And there is my coil. It's just a simple coil connected to a flyback there. We have a transistor acting as the kind of amplifier, and the signal. I'm basically sending a signal, a frequency from the microcontroller to the transistor's base, and then the power is going to the collector, then the emitter is going to the coil. As we can see here, I've got the oscilloscope hooked up to the coil, and then it's going back to ground. And then I just have a screen which also had a button, but my button is not working ever since I moved it place. So how I use a button is now I just short circuit that. Did you see on the screen? So every time I click or a short circuit, and you can see that the frequency has changed because I've got all these preloaded. So I'm going to short this again, and it's going to go back to root, as we can see there. So I've basically got it. It's just an array. I'll show you in a minute. An array that loops through text, and also it loops through frequency, and I can actually feel the effects of the coil. It's a lot more relaxed now. The energy is going down. You can see there. It's a lot more. Yeah, that's a lot nicer actually. So the way that this thing works is essentially it's signal to the coil. So the coil, it pulses at these are mostly around 200 hertz, so it's pretty low. Apparently 10 hertz and 20 hertz is actually what they use for like the really strong, those what's it called, pulsed electromagnetic therapy or something. This isn't pulsed electromagnetic therapy. It's similar to it. It's a lot weaker. It's more just to produce a magnetic field, a pulsed magnetic field of a certain frequency that relates to certain things and stimulates different like areas of the bodies. And I have the chakra frequencies here. So if I change it to sacral, so ghetto. Yeah, I had this button, but it just I think it works. It's just, I don't know. There's something wrong with my circuitry. Whatever that. I mean, look, this works, right? My short circuiting. Oh, that's solar plexus. Yeah, so I can feel now it's more stimulating, and again the frequency has changed. And then if I change it back to the heart frequency just by shorting that out, yeah, I could feel in my chest. I could feel it. There's like an energy field there, or it's sending my like energy, and it's sending pressure there is the best way to put it. So it's like controlling pressure. Basically what this circuit does is it controls pressure in the body. And again, yeah, we can see the here I'll change it to throat, and changed, and you'll see the signal change. I'll change it to third eye. Yeah, I can instantly feel pressure in my head. And I guess the frequency, I don't know, changes or something, and then we'll change it to crown, and you can see instantly it did that little doot doot. Again, I'm not really good at these things, but I've just got to the point where it shows something. So I don't know, and I can feel pressure in the crown, which is from this, basically just the magnetic field. It's very weak because I had to set up everything so it doesn't burn out the controller. But anyway, I'll show you it in a software view. So just quickly, for people who don't understand the circuit, I want to show you, this is essentially my interpretation, at least, of a rife machine circuit. We've just used 3.3 volts for this. You would use different voltage depending on what it is. So here we have our power supply. So positive is top and negative is the ground's bottom here. And then we have a frequency generator. So of course I was using the microcontroller as the frequency generator. So this, it wouldn't be the exact same circuit, but in general, if you would use a resistor just to control the voltage going in here. I think 3 volts is actually fine for most frequency generators, so you probably wouldn't need that. You can see it's hooked into the circuit like so. So you can use pulse wave generators, sine wave, whatever, whatever you can get your hands on, right? And it's essentially just the frequency going into a transistor or an amplifier. This can be replaced by an amplifier. Do you need a resistor here? Again, depends on how much output voltage your frequency generator is. Again, if you're using a MOSFET instead of a BJT, this would be a BJT, and also an NPN for the electronics people who know what that means. This would be a just a regular one. So it would be, 0.7 volts is the standard to turn on the base, because the way these things work is that you hook up power through the collector and it goes out the emitter. You think power collects and it emits. And the base is what you hook up to your frequency. This is the same way that music works. If you had like a guitar, you would be hooked up to the base, of the amp. Technically it's a little different, but you know what I mean. And then because this creates a frequency, the power goes through and it's get altered by the frequency, or the power gets amplified and tuned, I guess you could say, or changed to that frequency. So it kind of goes, whoa. And then here instead you could actually have speakers. This were a musical instrument, but what we have is we have an inductor here, and we have a diode, DD, and in. I'm still trying to figure out if this is correct and how this all works, but apparently this is called a flyback diode. So you'll notice that the negative is facing towards positive, right? Like this is positive and this is negative, which is the opposite of what you would usually do, because if I understand this correctly, if we go back to Steinmetz's book on the transient, when you have a collapsed magnetic field, and considering we're constantly collapsing the magnetic field, and when you turn it off, it'll like send all the power back, and the diode kind of helps it to not fry everything, because you're getting like tons of like high voltage, or hundreds of volts, not super high, but enough that it could fry the transistor, I guess you could say. So that's why we have the flyback. Is that correct? Is that not? I'm just trying to figure this out. So pretty much it's just frequency going to amplifier, in this case transistor, going to coil, positive and negative back there. And of course, as I said, you have the reverse diode, which is the flyback, and this is just in parallel. So you would connect coil positive to diode negative, diode positive to coil negative. Technically, does the coil have a positive and negative? Actually, it kind of does. If you flip them, it creates a different effect. And then that's just going back to ground. And this is just going to positive. Pretty simple stuff, right? So pretty much that's how it works. Again, as I said, if you had a speaker, this would create a frequency on the speaker. Okay, so here we are in software view, and actually the software was pretty simple, thankfully. Now this is Arduino IDE, which uses, I believe, C or C++, and C is a lot easier to write. So I'm not sure what the wire.h is, but the Adafruit stuff is just this is all for the screen, to use my model of screen. You don't have to use a screen. You could probably just use buttons and lights if you want, but whatever. So this is all just screen stuff. Now frequency select is my array variable, essentially. So the main thing works based off, you can see here I've got 2 arrays. Firstly, it says root, sacral, solar plexus, heart, throat, etc. And then we have our float, which is our frequency list. So essentially the frequency select will go into this array and be like, if it's set to 0, it'll be set to root, or if it's set to 0 on frequency list, it'll be set to this one here. And then essentially the button press, which I've got here we go, button pin here, and I've got my signal pin here. And this stuff is just for the frequency stuff. And anyway, we've got to get it started up, and then it's just like display stuff. I got a lot of AI help for the display stuff, but this is how you use this thing called LEDC attach, and then it's just like frequency signal pin, so the pin, and then the frequency we want, which is, as I said, frequency list, frequency select, which is currently set to 194.18 hertz, and then I don't know, resolution, I think that's volume, so 8 is 255 or 256 or something base volume, and then we set also like half volume here. I guess half volume is good, so it doesn't, like, I don't know if it'll burn itself out or whatever, because it is pulse, so it should be okay. So we just have on our pin, we're setting the volume of the signal, basically. I guess it should be fine. I also had a resistor. Then it's just display stuff, so it's clear screen, set text size, text font color, and then I'm not sure what to set cursor. I think that's where you, that's like the upper left point of the screen, and then it's just print frequency select, that's when it starts up, and then it's just selected plus the frequency, which is, so it's selected root or selected sacral, depending on this, which is that we have our signal pin, and then it's if digital read button pin equals low, specifically for input.pullup is to make it an input. If that is low, which, you know, it's kind of contradictory to be, you'd assume it to be high power. So basically, if we click our button, what happens is that we just plus our frequency select. I had forgotten the C syntax, so I just did the basic one. And then it's, of course, if our array is above 6, because it's only a 0 to 6 array, it's just some math to like fix that up. Then it's just reprint a screen and also have the frequency of the emitting pin be set to this, just to update that. And then there's a delay, so we don't overdo it. I probably should make the delay a bit larger. So pretty simple script. Really just clicking a button, just like getting all the screen stuff working, getting all the pin stuff, and then it's just clicking a button to iterate through the array, which changes the, I think if I could make like a phone GUI, I could make it a lot more complicated, but this is the best I can do for now for a microcontroller.